Hey boys and girls, Mr. D here again. In this video we're going to be looking at how to solve what we call literal equations, situations where we have more than one variable. Up to this point we've been solving equations that only have one variable in it. They've been multiple variables, but they've all been of the same kind. So maybe we've had multiple x's, sometimes even on different sides of the equation we've had to combine like terms with those x's or whatever variable it is and solve it that way. In these examples today, we're going to have more than one type of variable. So there may be x's and y's in the same equation. It sounds more complicated than it really is. Actually, a lot of times ends up being easier because there's less math computation involved. You just have to remember the basic principles that we've gone over about isolating variables. So take a look at the first example here. They're asking us to solve for the star. There's no numbers here. But again, if we're solving for the star, that means we've got to get the star alone. Get it all by itself, right? Whatever we're solving for, get it alone. Okay? So keep that in mind. Get it alone. So if I have smiley face plus star equals flower, do your best drawing those in, my non-artist people. We just have to subtract the smiley face from each side, right? And it's positive here, so subtract it from each side. And on the left side, we would have just a star remaining. On the right side, we have flower minus smiley face. These are not like terms. They're not the same, so we can't combine them. We cannot combine them. And that's it. We'd be done. Again, the star is all by itself, and we would just say, if they want us to solve for star, we'd say star equals flower minus smiley face. Take a look at this example. Solve for x. But oh my gosh, there's no numbers. Oh no, what are we going to do? Well, that's fine. We know solve for x means get it alone, right? Get x alone. So who cares if there's numbers or not? They actually made our life a little bit easier here. Think about all those times you're not sure, do I combine the numbers, do I subtract them, which sign is a positive, negative? Hey, it just became a lot easier. Plus p here, so let's subtract p from both sides. Subtract p from both sides. Well, n and p are not like terms. So on the right side, we just have n minus p. We can't combine them. They're not like terms. It's done. And on the left side, these cancel each other out. What remains is x. So we got x all alone. X equals n minus p. If they were asking us to solve for x, well, that would be our answer right there. X equals n minus p. Piece of cake. Okay, don't freak out when you don't see those numbers. Take a look at this one. Here they want us to solve for m, so we've got to get m all by itself. And if you look here, we've got m in a couple locations. We got on the right side, we got on the left side in parentheses. So remembers what we got to do here. Starts with the d. We got to do that distributive property. So negative 3 times m is negative 3m. Right, this will free up our variables out of the parentheses. Negative 3 times a negative 2n. Negative times negative, positive 6n. And then on the right side, we have our 5m. Okay, we've got to combine our m's here. So what I'm going to do is I'm going to bring this negative 3m over to the right. Since this 6n's over here, there's nothing else over here. It'd be one less move. If I bring this 5 over, then I've got to bring the 6n to the other side. So I can make it one less move. It's negative 3m here. Go plus 3m to both sides. Over here, negative 3m, positive 3m. It's going to cancel each other off. So we have our 6n as a Nancy remaining. 5m plus 3m is 8m. Okay, and then from here, we almost got the m all by itself. We have 8 times m, so we're doing multiplication. We just divide. Okay, 8 over 8 cancels out, so we're left with m on the right side. So we got m all by itself, which is what they're asking us to do. And we have 6 over 8 times n. We can reduce 6 over 8, divide both by 2. We get 3/4. You could write it as 3/4 n or we can try and extend that, or we can even write it as 3n over 4. Same thing, okay? But that would be your final answer right there. So m is all by itself, either one of those. Let's take a look at one more example here. It wants to find the value of x when m is these certain numbers. So let's get x all by itself. Okay. Moving this m over, minus m to both sides. So we have 4x equals 12 minus m. Okay, nothing we could do here. These are not like terms. Over here, we almost got the x all by itself. 4 times x. So we divide both sides by 4. That's a 4. Let's change it up. Okay, so over here, 4's cancel each other out. Only x remains. And we've got 12 minus m over 4. Now be careful. Oh, man. The 4 and the 12 cannot reduce in this format here. You'd have to reduce 12 by 4, and you'd have to reduce m by 4. This is probably the best way to leave it as for now. If you really wanted to, and I don't think you need to do it, but you could separate these. You could say 12 over 4 minus m over 4, right? You're essentially doing the reverse subtraction, right? You're keeping that common denominator. You could do that and then plug in for m, but I think this way is a little bit easier. So we're going to plug in for m from here. If you don't understand this right now, that's okay. You don't really need to, but some of you may see this. That's great. Let's plug in for m, okay, for the values that they're asking us to do. So x equals 12 minus 4, and wants to plug in where m equals 4. It's the first one. That's going to be over 4. 12 minus 4 is 8. 8 over 4 is 2. Okay, so x equals 2. Alright, so that's when m equals 4 up here. How about when m equals 8? 12 minus 8 over 4. Well, 12 minus 8 is 4. 4 over 4, it's going to give us 1. So x equals 1. And then the last one we're going to do is negative 8. So x equals 12. And let's be careful when we plug this one in. 12. Take that minus sign. Then minus 8. And minus minus, that's going to give me a positive. So if we rewrite this, what we actually end up with here is 12 plus 8 over 4. 12 plus 8 is 20. 20 over 4 is 5. So x equals 5. So there you go. There's some different examples. Remember, just keep in mind your basic principles. All right, regardless if they're numbers or not. Okay, just keep in mind your basic principles about getting the variables alone. Hope this is helpful. I'll see you guys in class.